semiconductor technology. Yet when you power our chip, you don't get data, you don't get light, you get a cooling effect.
How does the chip create cool?
So you drive heat from one side to the other, and the magnitude of that temperature gradient, coupled with the amount of heat it pumps per unit area, drives a cooling effect into the surface of the chamber that you want to make cold.
So let me see this for a moment. I can imagine if the existing refrigeration systems are heavy, and my understanding is they contribute to global warming and
toxic
all these
refrigerants, heavy,
things.
bulky, mechanically driven.
This would allow you to do cooling in a lot of different ways, is that right?
Different applications. So the reference design built around the chip, coupled with the chip that brings it to life, gives us tremendous flexibility as to where we apply our cooling. Flexibility you can't get with a compressor system because of its toxicity, its weight, or its electrical requirements that relegate it to certain areas of its use.
Where does the heat go?
So the heat's rejected into the ambient surrounding. The difference is we use the entire surface area of the shell, so there's never any one hot point of the product that precludes its use in compact space.
This is plugged in right now?
This is a great example.
Do you mind if
Please do.
Test it out?
Test it out. We want you to sample
Because we all
and
know
taste
those big, coolers when you're in a convenience store and they've got all the heat coming out the back.
You captured it. Our partners at Unilever came to us with a demanding
back
challenge.
here.
They wanted to position and profile product right at the point of sale, the most demanding and high-profile, high-profit area of a grocery store. Yet when they placed a compressor, the waste heat and the electrical requirements drove that compressor to the back of the store. Now you have ice cream and some of the most famous brands right at the point of sale. And that approach, from a reference design to the components that bring it to life, now enables cold chain, consumer products, and even air conditioning.
Can you, I want to talk about the drone, but
Sure.
Can you scale this beyond the size of something the size of a microwave or even this drone to something the size of an industrial refrigerator or a truck?
That's the modular nature of the chip assembly, is we can scale up or down, cooling the most sophisticated fiber optics to the large refrigerator systems that you might see in residential or industrial use.
So who are some of your current corporate partners and who could be on the horizon?
So if you look on the industrial space, Unilever is a partnership that we have in commercial and industrial refrigeration. If you look at cold chain transport, planes, trains, automobiles, or drones, the weak link in cold chain logistics is how to deliver any perishable good at the appropriate temperature. With Precision Hawk, we've been able to provide a compact solution that runs off battery power with the drone itself, that you now have an effective.
So you're cooling the drone, or we're cooling the box? The drone.
So
payload.
The drone is the true vehicle. We're cooling its payload.
So you can get me Dairy Queen delivered to my house.
I can get you Dairy Queen. I can get you organs for the medical space.
Wow.
It's all which preference you have.
Well, I've been holding on to this for the last minute or two, and it's still so cold. My hands are going down. I don't even want to bite it. I'll get a headache if I do.
But this gives you a sense, from consumer products for a comfortable night's sleep with our partners at Bright Bedding, to taking on the environmental challenge of our time in air conditioning with partners at the Temasek Ecosperity Foundation in Singapore. There's that scalability that you referenced with the design and the manufacturability of the component.
Very